Hello second graders, welcome to Temperature Changes Matter. Today we're looking at melting butter. Two friends are melting butter. Which friend has the best claim about the butter? So Lana says melted butter can change back to solid butter. And Tony says melted butter cannot change back to solid butter. Who do you think is right? Do you think that melted butter can change back into solid butter? We'll investigate, and by the end of this chapter, we'll know the answer. Let's watch the video of the artist heating the glass ball. So what are some questions you might have about the heated glass? Maybe we're asking, why is he heating the glass? Will the glass change shape? Maybe, how hot is the temperature? As a welder, I use heating and cooling to put materials together. I am interested to see other ways heating and cooling change matter. Let's listen some more about matter, temperature, and change.
Matter, temperature, and change. Heating and cooling change matter. Imagine holding a rock in your hands. It feels cool, hard, and solid. Yet, a rock can change from a solid into a liquid. A solid rock can become liquid because heat can change matter. Sometimes the change is lasting, but sometimes it is not. Melted rock flows down the side of a volcano. Temperature is a measurement of how hot or cold something is. A thermometer is used to measure temperature. Inside a volcano, the temperature gets so hot that some rock melts. The melted rock flows down the sides of a volcano when it erupts like a hot river. When the liquid rock cools, it changes back into solid rock. Melted rock cools and becomes solid rock. Hot matter can evaporate. To evaporate is to change from a liquid to a gas and go into the air. Water evaporates from oceans, rivers, lakes, and moisture on the land. Heat is needed for a liquid, such as water, to change to a gas. Water evaporates into the air. The higher the temperature, the faster a liquid evaporates. For example, a rain puddle evaporates more quickly when it is hot outside than when it is cool. Just as heating a liquid changes it into a gas, cooling a gas can change it back to a liquid. The steam is water turning into gas. Cold matter can condense. You may have seen water drops appear on the inside of a window on a cool day. The warmer air indoors holds water vapor. Water vapor is water that has evaporated and gone up into the air as a gas. When that air is cooled against a cold window, the gas changes back into a liquid. Gas condenses into liquid. When a gas changes to a liquid, it condenses. Water condenses outdoors, too. When water evaporates into water vapor, it mixes with air. When air containing water vapor cools, the vapor condenses back into a liquid. The gas in the warm air turns back into water when it touches the cool glass. Cold freezes and heat melts. Water also can become a solid. When a liquid becomes very cold, it changes into a solid, or freezes. Ice is the solid form of water. An iceberg is solid water. Water freezes into ice and icicles. Heat is a kind of energy that makes objects feel warm. Heat causes solid objects to melt or change from a solid to a liquid. Snow and ice will melt from the warmth of the sun. Even an iceberg will melt when the temperature rises for a long time. Very little heat is needed to melt matter such as chocolate and butter. Too much heat can burn or damage and change an object. Heat from the sun causes solid objects to melt. Some changes last. Heating and cooling matter can change it. Wax is melted to make a crayon or a candle. The liquid wax is poured into a mold to shape it. Then the mold is cooled with cold water. Now the wax changes back to a solid. Hot wax is liquid. Cool wax is solid. Sometimes a change to matter cannot be reversed or changed back. When a candle is lit, the heat from the flame burns the wick. Once the wick burns, it cannot change back to the way it was. When wood is burned in a campfire, it turns to ash. Ash can never be changed back into wood.
So what are some words that we've learned? Temperature. We've learned that temperature is a measurement of how hot or cold something is. We know that because sometimes when we have to take our own temperature, we're trying to find out how hot or cold we are. A thermometer is the tool that we used to measure temperature. So a thermometer will help us find out how hot or cold something is. Evaporate is when a liquid, such as a puddle of water, turns into gas. So this happens when there's heat. When there's heat in the puddle, it changes from liquid into gas. Condensation, or when something condenses, it's the opposite. It's when the gas, particles of water in the air, can turn back into liquid. And that happens with cooling. Freezing is when a liquid becomes very cold. When a liquid becomes very cold, it changes into a solid, or we can say it freezes. Heat is a kind of energy that makes an object feel warm. Heat causes solid objects to melt. And now we know the answer to the first question we had. Can butter change back into solid butter? Can melted butter change back into solid butter? The answer is yes. If we add heat, the butter melts from solid to liquid. And if we cool it, the liquid becomes solid again. Too much heat can burn or damage an object, such as if you burn paper or if you burn wood, it changes from what it is into ash. Heat and ice. How can heat change ice? In which cup will an ice cube melt faster? So for this experiment, you would use 2 cups of water, permanent marker, thermometer, and ice. Label 1 cup cold and 1 cup warm. Take the temperature of the cup of cold water. Take the temperature of the cup of warm water. So the cold cup of water might have a temperature of, say, 5 degrees Celsius. And the warm one might be something like 25 degrees Celsius, for example. And then add an ice cube to each cup. Wait for 15 minutes and observe, and then measure the temperature of the water again. So you can write your results here and find out the temperature of the cold, using a thermometer, of the cold water after the ice and the warm water after the ice. And record your observations and draw. So how did the temperature of the water affect the ice? So the cooler water would make the ice melt. The warm water would also melt. However, with the cold water, it might melt slower than with the warmer water. It would melt faster. How did the temperature of the water change after putting the ice in it? Because the ice is cold, the ice would make decrease. That means get colder. Because you're adding something cold to the water, so the water becomes colder. Hello again, class. If you remember, we previously looked through some of the meanings of these words in the text. Temperature, condense, melt, thermometer, freeze, burn, cool, heat, and evaporate. Let's try to see what each of them mean. Evaporate. Remember, evaporate is what happens to a puddle on a warm day. It's when the liquid becomes air or gas again. So evaporate is to change from a liquid to a gas and go into the air. So that's what evaporate is. Condense. Condense, remember, we said is the opposite of evaporate. So condense is when it's a cooler day and the gas particles or the water particles from the air turn back into liquid water. So it's a change of gas to a liquid. Condense is when a gas changes to a liquid. Freeze is when you cool something and it becomes solid. So freeze is when an object becomes very cold and changes to a solid. Melt, we said, is the opposite, when there's heat and something that is solid becomes liquid. So melt is a change from a solid to a liquid, like when you melt a piece of solid butter into liquid butter. And burn is to add too much heat that an object or some matter cannot go back to its original state. So burn is to damage and change an object. Now let's put a circle around the changes that are reversible, that can go back to normal, and an X over the changes that are not reversible, that cannot go back to normal. So wax melted to make a candle. So yes, the wax can be changed from the candle back into melted wax. So if you have some liquid wax and you cool it to make a candle, a solid candle, if you melt that candle, it can go back into liquid. What about wood burned in a campfire? So we put a cross here because we cannot change the wood that is burned, that will now be ash, back into the solid wood. What about lava that came out of a volcano? So now the lava would be liquid. Would that be able to go back into solid rock? If you cooled the lava, it could be solid again. And what about water that evaporated from a puddle? Yes, because we said evaporation happens, and the opposite of that is condensation. So if we added cool air, or if it was a cooler weather, the water that evaporated, that was now gas, can change back into liquid. Investigate how cooling and heating affect different materials by conducting the simulation. Answer the questions after you have finished. Name one object that goes through a change that is reversible. So we can say an ice cube, because an ice cube is reversible. You can melt the ice cube and then you can cool the ice cube. How do you know the change is reversible? Because you put the ice cube in the sun, and then when you put that liquid back into the freezer in a mold, an ice cube mold, it changes back solid ice. Name one object that goes through a change that is not reversible. So an object that once you add heat or cool it, it cannot go back to how it was before. And how do you know? So one example could be popcorn. when you heat popcorn, a kernel, it pops into corn, pops into popcorn. But if you cool it, it cannot go back into the kernel. We can say the same for paper. If you burn paper, or if you add too much heat to paper, it becomes ash. And if you cool the ash, it doesn't become paper again. So let's fill in the blanks. Heating A changes it into a gas. So what do you heat to change it into a gas? And cooling A changes it back to a liquid. So heating a liquid changes it into a gas, right? This is called evaporation. And then cooling that gas changes it back into a liquid. Remember, this is called condensation. So we previously read or watched the video Changes in Matter. You can go back to that video and watch it again if you want. And so we can answer these questions. How can a candy bar change states from a liquid to a solid? So a candy bar is something like, let's say, a chocolate bar. How does it change from a liquid to a solid? If it's a liquid, it means it's melted. So if we cool it or freeze a chocolate, it changes back from a liquid, the melted chocolate, to a solid. So that's what we have to do. We have to cool it or freeze it. Read Temperature Changes Matter on the ways matter changes with heating and cooling, and then answer the questions. Temperature changes matter. Chemical changes. Matter can change in different ways. One way is a chemical change. The matter becomes a new kind of matter with different properties. Heat can cause a chemical changes in matter. When matter goes through a chemical change, it is not easy to change it back. For example, when you burn paper, you cannot change it back. Seeing light and feeling heat are clues that a chemical change may be happening. Heat causes the matchstick to burn. What properties of the matchstick have changed? So properties are things like color, shape, smell. So if you use the matchstick, it changes from red to black. It also becomes softer, so if you were to touch it after it cooled, it would fall in your fingers. The smell changes. So these are all chemical changes that change the property of the matchstick because we've added too much heat. Heat causes the egg to go through a chemical change. You can see and smell. Changes of state. Matter comes in different states. What are the different states? Solid, liquid, and gas. Heating and cooling can cause matter to change states back and forth. Let's see how this works for water. Ice cubes melt into a puddle of water when heated. Melting is a change from a solid to a liquid. If more heat is added, the water evaporates or changes from a liquid to a gas. Water as a gas is called water vapor. Water vapor condenses when cooled. Condense means to change from a gas to a liquid. This is why you see small drops of water on the outside of a cold bottle. When water cools even more, it freezes or changes from a liquid to a solid. It goes back to ice. So what are the clues that a chemical change may be happening? We can see changes in the property of our matter, such as the smell, color, feel, So now let's try this fun research, investigate, and communicate inquiry activity with an adult. Now you choose an object to observe as it is cooled and heated. So for this we'll need a variety of objects, a freezer, and a microwave oven. Choose one of the objects provided by your teacher or parent, and then see what will happen when you cool and heat your object. So you're going to cool it by putting it in the freezer, and then you're going to heat it by putting it in a microwave oven. And will the changes be reversible? Some things you could choose are things like ice cubes, maybe a slice of apple, and any other things you can see around. What steps will you use to do your investigation? So write down the steps you would take, what you would do first, and then second, third, and fourth. Write down the object here and what happened when you heated it in the microwave, and then what happened when you cooled it in the fridge. You can have 2 of each, so you can have 2 ice cubes. Put one in the microwave and cool the other. How did your object change when you heated or cooled it? And can the change to your object be reversed? Tell how you know. So to do this one, you would heat your ice cube, for example, and then you would try to freeze it back in the freezer and see if it would go back into solid after being turned into liquid. You will use what you have learned about cooling and heating matter to draw what happens to butter throughout the day and night. Make a prediction. What will happen to a stick of butter that was in the sunlight during the day and then left in the kitchen at room temperature overnight? So to do this, you would fold paper into thirds. In the first section, draw what the butter looked like when it was put out in the morning. In the middle, draw what the butter looked like in the middle of the day when the sun was shining on it. And in the last section, draw what the butter looked like at night when it was at room temperature. Think about the video of an artist heating a glass ball at the beginning of the lesson. Use what you have learned to explain how heating and cooling helped shape the glass. So remember, when you heat something, it causes it to become more liquid, and then that will allow you to change the shape. And when you cool it, it becomes less liquid, so it becomes solid, and the shape is less likely to change. I'm going to leave you with a video on changes of matter that you can watch and find out more about how these changes happen. I'll put the link in the YouTube description.